All right, so this is lesson P2, linear models and rates of change. So starting off with the kickoff, those three types of symmetry is what we talked about the last time. Those are the x-axis, y-axis, and origin. So x-axis is when we put a negative y in, and if that didn't change the sign, so if those exponents were negative or even, then that would be the x-axis symmetry. So across the x-axis, it would fold over, it would match up. Y-axis is when we put that in for x, and we get the same thing out. So then that'd be symmetric about the y. We could take it across the y, fold it up, and then origin is when we can take it, turn it 180 degrees, and it would match back up. So really what we're hitting here is just slopes and equations of lines. So slope really is your change in y over the change in x. So subtract your y's over your x's subtracted. That's how you get slope of the line. So positive slope is as you go from left to right, the line is going to go up. Negative, it's going to fall as you go from left to the right. No slope, think of that as zero slopes. That's when we have a horizontal line. And undefined slope is when we get the vertical line. Point slope form of a line is y minus y1 equals m times x minus x1. Your y1 and x1 are the coordinates of that point, and your m is your slope. So if we have something like this, we would fill in y minus the x, so minus a negative 2, equals our slope of 3 times x minus our x of our point, which is 1. These will cancel to be positive. So this is really y plus 2 equals 3 parentheses x minus 1. Now if we go through and solve for y, we would distribute that 3 in and have y plus 2 equaling 3x minus 3. Subtract your 2 over. And now we have y equals 3x minus 5. And that's your slope-intercept form. So here what's in front of x is your slope. That's your m. B here is what's added or subtracted on the end. That's going to be the y-intercept. So where you're going to cross the y-axis. So the big thing is rates of change. So it's just the ratio of two changing measures. So think slope. Here our rate of change was how y changed compared to how x changed. We can use anything, any two measures, and we're just going to compare how they're changing. So for example, we could check or find the change in the population. So we're looking for average rate of change here. So population of Kentucky was 3,687,000 in 1990 and 4,042,000 in the year 2000. Over this 10-year period, what was the average rate of change? So we're looking for people per year that it's changing. So we're going to do the 4,042,000 minus our 3,687,000 over our 10 years. We already know it's 10 years between 2000 and 1990, so we can simplify that part. When you subtract this, you're going to end up with it's like 355,000, I believe. Yeah. Over 10, so that zeros are going to cancel, and you're going to end up with 35,500 people per year. Okay, so rate of change, just how is one quantity changing compared to another quantity changing? When we have it in this form, which this is your general form of a line, how we find that is, first we're going to have only x and y on the one side. We want to move this constant over, so we're going to add the 6 to the other side. And we have 3y plus x equaling 6. So to find your x-intercept, we're going to cover up the y, so x would equal 6. And then to find the y-intercept, we're going to cover up the y. We would divide them by 3 and get y to equal 2. So when we go to graph that, we just have to graph those intercepts. So 1, 2, 3, 4, 5, 6, somewhere here would be on the x. Y is only up 2. And then you draw your line through those 2 points. And that's how you would go ahead and graph it when it's that way. That's the easiest way to do it. Otherwise, you could go through and solve for y and get into slope-intercept form, and you can graph it that way. Keep in mind some things. So graph of a vertical line is going to be x equals a. So it'd be through whatever that x is, you'd have the vertical line. And y equals b, so whatever that b is, you would have the horizontal line cutting through there. When it comes to slope, keep in mind parallel lines are going to have the same slope. So whatever one has, the other one will have. Perpendicular, it's going to be the opposite. So the negative reciprocal. So if this is m1, you would flip it over and negate it to get the second slope. So we have these general forms of the equation of a line. We also know that these lines are going to pass through the point 2, -1. So knowing that, we first need to find the line that's parallel. So if we take this one here, 2x minus 3y equals 5, we need to find its slope. So we're going to solve for y in this case. So we're going to move the 2x over and have -3y. So if I minus the 2x, minus the 2x. So -3y equaling -2x plus 5. I'll write like that because I'm going to try to get into slope-intercept form here. So I'll divide by -3. This gets divided by -3, and this gets divided by -3. So y would equal, the negatives would cancel, 2/3 x minus 5/3. Now, for this, we just need slope. So this is all we're really concerned about. So m is going to equal 2/3. So if we're going to be parallel to this line, we're going to have the same slope. So for a here, we're going to use our point and use point slope form. So y minus the y of the point, so plus 1, equals that same slope of 2/3, and then x minus the x of our point, so minus 2. And that would be an equation of a line that's parallel. Typically, we don't leave it like this. We're going to go ahead and solve for y. So if we distribute this in, we're going to get y plus 1 equals 2/3 x minus 2 and 2 would make 4/3. And then if we subtract 1, y would equal 2/3 x. 1 is really 3/3. We're already negative, so this makes it a minus 7/3. And that's how we would end that one. For b now, we want to be perpendicular. So here our slope for the second one needs to be the opposite, so it's going to flip over and then negate. It's going to switch the sign. Still going to use the same point. So y plus 1 equals now a -3/2 x minus 2. Using the same point so the x and the y don't change. From there we still distribute. So y plus 1 would equal a -3/2 x. 3/2, the 2's would cancel, which would make this a plus 3. Which makes it really nice. And then we'll subtract 1. So y would equal -3/2 plus 2. Because, again, keep this in mind, this is 2/1, so that's why the 2's cancel. But that's it. That's the lesson. Let me know if you have any questions.